This is 11.3 polar coordinates. So we're all familiar with Cartesian or rectangular coordinates where you're just plotting x and y. So pretty straightforward. You just find the x coordinate, y coordinate, where they meet. You put a dot there. But what about polar coordinates? So we have a r and a theta, which is like the radius and an angle. In order to graph this, first you have to do your angle, and then you do your radius, and you find your point. I guess you could draw both these and find where they intersect, but we're going to do a bunch of examples. So where would A be? So we do the angle pi over 6 first, which is pointing this direction, and you count out two circles, so 1, 2. So our first point there would be A. All right, so there's a bunch more points here. You can try them out. So go ahead and pause, plot these points, and check your answers. Welcome back. So B, you go negative pi over 6 in 2 spaces. Well, negative pi over 6 is over here, and you go 2 spaces. You should be right there for B. So we put B right here. Keep going. C. Oh, C and A are the same. Loser. Okay. D. Now we go pi over 6, but what does that negative mean? You go the opposite direction. So pi over 6 is right here. But the negative 2 says you go the opposite direction 2 spaces. So we go 2 in the opposite. You end up here. So that's going to be D. E, it's right there. So 7 pi over 6 comma 3. 7 pi over 6, you work your way this way. And there's 7 pi over 6. So you're pointing that way, and you're going to go 3 spaces for that. 7 pi over 6, 3. So if you go 3 spaces, 1, 2, you'd be right here. All right, that was D? Yeah, because C and D were the same. Let's do E. So 7 pi over 6, 3. So 7 pi over 6 is that way, but we're going to go 3 spaces. That's going to put us there, and that's going to be E. Now negative 5 pi over 6, negative 2. So negative 5 pi over 6, you go backwards. There's negative 5 pi over 6. But the negative 2 says you go the opposite direction. You end up at the same spot as A. So we can label that A or F. And then pi over 2, 4. Pi over 2 is straight up. You go 4 spaces. 1, 2, 3, 4. That's going to be 4 comma pi over 2, which is G. And then 4 pi over 3, negative 3. So 4 pi over 3, there's 1, there's 1, 2, 3, 4 pi over 3 is down here. So that's 4 pi over 3, but it says go negative 3. You're going to go the opposite direction 3, so you're going to end up with a point over here, and that's going to be H, because we went the opposite direction. That's H. Negative 3 pi over 6, negative 1. 3 pi over 6 is negative 1/2. Again, kind of a lame-o. So negative 3 pi over 6 is negative 1/2, but our units is negative 1. That means we go the opposite direction in 1 space. We end up there. So that point becomes I. And then J, you go negative 2 pi and negative 2. Well, negative 2 pi, you end up here. And then it's saying go negative 2. You go the opposite direction 2. You end up here. That's going to be your point. And that we're going to call j. So those are all the polar points. Now Cartesian, 3, 4, that's easy. Right 3, up 4. That's A. B, negative 2, 5. Negative 2, 1, 2, 3, 4, 5. That's going to get me a B. So the next two, why did I have it? The first one was A. Oh, that is an A. C is negative 5, negative 1. So I go left 5, negative 1, and 6, negative 7. 1, 2, 3, 4, 5, 6, right? Down 7. Going to be the last point there. There we go. All right, converting between Cartesian and polar coordinates. This shouldn't be too bad. I'm going to draw a general point out here. And that's going to, let me draw. Okay, that's going to have an x component, a y component. So let me draw the x and then draw the y. And we have an angle theta, and we have a radius r. Now, so we have a point in space, namely this point here, and it can be defined either with an r and theta, or it could be defined with the x and a y. And either way, you get the same point. So how do you convert between the two? So we're going to use trig. If you look at this angle, sine is opposite over hypotenuse. So you would say sine of theta is the opposite side over the hypotenuse. Okay? If we multiply both sides by the radius, y is r sine theta. So that's your first equation that you will use. Then similarly, you could say cosine of your angle. So if this is your angle, cosine is adjacent over hypotenuse. It's going to be x over y. Multiply. Wow. Multiply both sides by y. Oh, I know what's going on. It's r. I was so confused. Hypotenuse is r. Multiply both sides by r. You get x equals r cosine theta. So that's where this formula comes from. And then if you look at this, you have a right triangle. Pythagorean theorem applies. X squared plus y squared is r squared. So there's our r equation. And then the arctan, because opposite over hypotenuse is tan, so arctan of y over x is theta. So we get that formula. Or tan of theta is y over x, so tan is opposite over hypotenuse. You arctan both sides, and you get theta is arctan of y over x. Okay? So that's how you convert. Those are the 4 formulas. I will double highlight. Those are 4 formulas that you'll use to convert between polar and rectangular and backwards. Okay? So next, we're going to practice converting. Okay? So we have 4 Cartesian coordinates. And we want to convert this to polar coordinates. Okay? No, the other way around. These are polar, and we want to convert them to Cartesian. My brain is shutting down. I got to wake up here. So x is r cos theta, and y is r sine theta. So basically, we're just going to plug in our r and our theta, and quite simply get our answer. So x is 4 cos pi over 2, but cos of pi over 2 is 0. And y is 4 sine of pi over 2, but sine of pi over 2 is 1, so we get 4. So our coordinates will be 0, comma 4. And we're going to do this for the next 3 problems here. X is r cos theta, and y is r sine theta. Well, cosine of negative pi over 6 is radical 3 over 2. So we get radical 3. And sine of negative pi over 6 is going to be negative 1/2. So we get negative 1. And there are our x and y coordinates. I'm out of room. I didn't leave myself enough room for these problems. All right, let's just keep going. Oh, I see what I'm doing. No, I don't. Yes, I do. Okay, keep going. Sorry. R is negative 2. Cosine of theta is negative 2 pi. Y is r times the sine of theta. Okay, so cosine of negative 2 pi is 1, and sine of negative 2 pi is 0. So we have negative 2, 0 for our third one. And the last one, you get the idea. These are pretty straightforward. R cos of our theta and r sine of our theta. So cosine of 4 pi over 3, that's going to be negative 1/2. So we're going to get 3 over 2. And sine of 4 pi over 3 is going to be negative radical 3 over 2. So you can get positive 3 radical 3 over 2. And those are the coordinates of my last one. All right, now we're going the opposite direction. We have x and y. We're trying to find r and theta. Pythagorean theorem, x squared plus y squared, square root, and you get an answer of 5. For your angle, it's arctan of y over x, but you're going to have to do that in a calculator because who can do that in their head? So I'm going to punch that in real quick. And we're going to get 0.927 about. So that's going to be our conversion for that one. Let's keep going. R is going to be x squared plus y squared square root, which comes out to be 13. And then your angle, here's where you have to be careful, and I'll talk about this. It's opposite over hypotenuse, but I have to add pi, and let me explain why. So your calculator, and I don't think I even explained this back here. So theta, opposite, adjacent, the tangent of theta is opposite over adjacent. Tangent of theta is y over x. But if you arctan both sides, you get theta is arctan y over x. But your calculator always assumes that you're either in the first or fourth quadrant. All your angles will be those quadrants. So for example, suppose you have the coordinates. I'll give you an example. If you arctan, let me start with coordinates. Actually, let's do this example since we're doing it. Where is negative 5, 12? Negative 5, 12, it's going to be somewhere over here. Okay? We arctan that, and I'm going to tell you what angle I get here. I'm going to pop that in a calculator. My angle comes out to be negative 1.176. That's down here. It found that. Why did it do that? Because this, if the 12 is negative and that's positive, that's going to put us down here. And If the 12 is positive and the 5 is negative, that's going to put us here. Well, the calculator doesn't know the difference because a positive divided by negative or negative divided by positive is the same thing, so it always assumes the x is positive and the y is negative. So therefore, we're going to be in the wrong quadrant. Therefore, if it puts us down here, we have to add pi to get to the right place. So that's where that plus pi comes from. And that's the answer to the second question. We're going to keep going. What's r? Square root of 1 squared plus negative 2 squared. So r is going to be radical 5. And theta is arctan of y over x. I just popped that in the calculator to get my answer. And I get negative 1.1. So that's C, uno más. Here we go. So how do I find my r? Square root of negative 1 squared plus radical 3, negative radical 3 squared, which will be 2. But then, here we go. Arctan of y over x. Now, here the negatives cancel, and you get a positive number. So when you do this in your calculator, actually even without the calculator, I can do this. If you cancel out those negatives, or if you do it on your calculator, you're going to get pi over 3. But here's a problem. Where is this point? Negative 1, negative radical 3. Negative 1, negative radical 3 is actually going to be over here somewhere. Negative 1, negative radical 3. But your angle we got here, pi over 3, is actually over here. So we're 180 degrees off. We have to add pi to get to that angle. That's why we need to add pi whenever, what's this doing? Whenever I get a negative x, because my calculator is not smart enough to figure it out. So it's going to be 4 pi over 3 for that last one. We have to convert the following polar equations into Cartesian. All right, we're going to use the same 4 formulas right here. Those you have to know inside and out. So part A, this one's pretty simple. R sine, we know that's y. Y equals 3, done. That's pretty simple. B is a little more confusing because we have a cosecant, and all our formulas are sines, cosines, and tangents. So we need to convert this into 1 over sine theta. And then I notice, gee, I wish I had an r here. So 2 ways. You can multiply both sides by sine theta. If you do that, you're going to have an r sine theta, which just is simply a y. Or the other way, you said, I wish there was an r here, but you're allowed to divide both sides by r. If you do that, you get 1 equals 3 over an r sine theta is y. Multiply both sides by y, you get y equals 3. Bam, done. But at the same time, we could have done where we multiply both sides by sine theta. Let me show you the other way, and you get the same answer. So multiply both sides by sine theta. Those cancel. You get r sine theta is 3, but r sine theta is y equals 3. So you converted it to Cartesian coordinates. Next one, again, we only have sines and cosines. So we are going to convert cotangent into cosine over sine and cosecant to 1 over sine. Now, I'm going to go through the same process. I wish there were an r here. Well, I'm allowed to multiply both sides by r. I can do that. Then, you wish there was an r here and an r here. Well, I can divide both sides by 2 r's. You get an r there and an r there. The left side becomes 1. R cos is x, R sines are y. I get x over y squared, and I end up with this when I multiply both sides by y squared. And then the next one, golly gee, I wish there were r's in front of these signs in cosines. I wish there were r's there. So I can't just magically put an r there, but I could divide both sides by r. That's a rule of algebra, that's okay. If I distribute that r to both of these, I end up with 2r cos theta plus 3r sine theta. And now we're home free because r cos is x, r sine is y. Multiply both sides by that denominator. Bam, I get that. So those were pretty easy. Just making sure that I just get what I need using the rules of algebra. And these next 4, I'm going the opposite direction. I want to go to x's and y's. Okay. Is it the opposite direction? Actually not. I'm going the same direction. These were supposed to go the opposite direction, but I didn't set it up right. You know, I kind of messed up, but oh well. I'll have to fix it next time. Let me do C and D here because they're a little bit different. So I asked myself, what do I do with that theta? I wish I could do something. But in our formulas, theta is arctan y over x. So I'm going to make this arctan y over x. I'm just replacing it with the equivalent. To get rid of tan, I'm going to tan both sides. And these are going to cancel. I get y over x. And the tan of pi over 6 is 1 over radical 3. I multiply both sides by x. Bam. I've got that. And for part D, I don't want r, I want x's and y's. So if you look at the formula, we have this, right? So I can replace r. Well, let's do this. R squared is x squared plus y squared. Square root both sides. And I get that. So I'm going to replace that with x squared plus y squared is 3. Square both sides. And there's my equation. And if you think about it, that's a circle with radius 3. What's that? It's a circle with radius 3. Makes sense. Let's keep going. How do you graph polar equations? If we have the polar equation r equals theta, how do you plot that? Well, we're basically going to make a table of values. And then we're going to plot those table of values. And that's going to give our equation. So that's the plan of attack. Okay, we always are in radians in calculus. So in radian mode, if r equals theta, if you plug 0 here, you're going to get 0. Pretty straightforward. If you plug in pi over 2, r is pi over 2, which is about 1.6. Pi is about 3.1. 3 pi over 2, you get about 4.7. 2 pi is 6.3. I'm just going to fill this chart. If you don't believe me, you can double check. There's a good chance I've messed up because I was getting really tired. And we're going to graph this. And point by point, going to connect the points. So we need to decide what each band's going to be. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like we can just make them 1 each. So 0, 0. I do an angle of 0 and an r of 0. I'm right there. Next, I'm going to be pi over 2. I'm in this direction, and my r is going to be 1.6. So 1.6 is around there. And then pi, I'm going to be 3.1. So pi is that way. I'm going to go 3.1. 1, 2, 3.1, right around there. At 3 pi over 2, I'm going to be 4.7. 3 pi over 2 is that way. I'm going to go 4.7. 1, 2, 3, 4.7. I'm right around there. I'm going to keep going. 2 pi is 6.3. 2 pi is this way. I'm going to go 6.3 dots. 2, 3, 4, 5, 6.3, right around there. And then 5 pi over 2 is straight up, and that's going to be 7.9 in that direction. So let me count. 2, 3, 4, 5, 6, 7, right around there. 3 pi is this way, and that's going to be 9.4. 1, 2, 3, 4, 5, 6, 7, 8, 9.4 is going to be about there. 7 pi over 2 is pointing downwards, and that's going to be 11. I believe 11 is right there. And then 4 pi will be 12.6. 4 pi is that way. 12.6, I believe, is going to be out here. Now, if you connect that, here's what you get. It's called the wow, it's not a very good connection. Spiral of Archimedes. You get the idea. It just spirals outwards. That was very bad. Very bad. Okay, so you just plot your points and start connecting them to get your graph. So you guys can try this one, pause, and then come back and see if you got it right. Well, I'm going to quickly, you just punch these in your calculator and make sure you're in radian mode, and you get these values. 1, 1.5, 1.7, 1.9, 2, 1.9, 1.5. I'm off a little bit here. This is 1. This is 1.5. 3 pi over 4. It's 1.7. Okay, that makes more sense. Then we're going to get 0.5, 0.3, 0.1, 0, 0.1, 0.3, 0.5, and 1. So you just punch those in your calculator, you get those values, and now we're going to plot them. 0, 1. And I'm going to make this first ring here 1, that 2, that 3. I think I'm going to do that. So 0, 1 is going to be right there. Pi over 6, 1.5 is going to be there. Pi over 4, 1.7 it's going to be about there. Pi over 3, 1.9 is going to be about there. Pi over 2, 2 is going to be here. 5 pi, wait a second, 2 pi over 3 is going to be 1.9. 3 pi over 4 is going to be 1.7. And then 5 pi over 6 is going to be 1.5. And then pi will be 1. 7 pi over 6 will be a half. 5 pi over 4 is going to be 0.3. Where am I? I just got lost. 5 pi over 4, there it is. It's going to be 0.3. That's it's going to be down here. 4 pi over 3 is going to be 0.1. Wow, so that's going to be hard to draw. And then 3 pi over 2 is 0 at the center. And then we're going to have a 0.1, which is really hard to draw. A 0.3 for 7 pi over 4. That's going to be really hard. 0.3. And the 11 pi over 6 will be 0.5. A little bit easier. And so I'm going to start here, and it's just going to connect. It's going to go this way, and then it's going to end right there. So that's just how to graph polar graphs. So it's important to see just how they're formed, how you find the points, and you make sure you know how to do that. And so we're going to make some connections here. So from 0 to pi over 2, these are an x and y coordinate, or a theta and r coordinate. These are polar coordinates. So this is saying at 0, r is 0. When theta is 0, r is 0. Right here is going to be pi over 4. When the angle is pi over 4, my r is 3. When my angle is pi over 2, my r is 0. When my angle is 3 pi over 4, r is negative 3. And so how is this going to play out? So as my angle goes from 0 to pi over 2, my radius starts at 0, gets bigger, and back to 0. So as I go from this angle to that angle, 0 to pi over 2, my r gets bigger, bigger, bigger. It's maximum at pi over 4, and then it gets smaller, smaller, smaller. It shrinks down at pi over 2. So that's why those two correspond. Now from pi over 2 to pi, that's from here to here. What's going on? Well, your r's are negative. You're going to go in the opposite direction. So at first it's going to go smaller, bigger, bigger negative, smaller negative, 0. So as you go through these angles, you're going the opposite direction. A small negative, a bigger negative, biggest negative, smaller negative, back to 0. So this is produced by that side. So you have to be able to see that. And this is pi to 3 pi over 2. That's from here to here. My r's are positive. It goes out small, bigger, bigger, biggest, smaller, smaller, 0. So small, bigger, bigger, biggest, smaller, smaller, 0. And then from 3 pi over 2 to 2 pi, that's from here to here. My r's are negative. So as I go through these, I go the other direction. Small, bigger, biggest, smaller. And that produces that. So spend some time and make sure that you're connecting between those two. And I'm going to do 2 more and see if you can make these connections. We have 2 more of these to do. So you can pause and try to do this on your own and see how you do. I'm going to try to color code this the best I can. So we're going to do this section right here. I don't know if you can see that. We're doing this section. So it's negative r. So when you're starting at 0, your r is negative 1. That means we are going to be right there, because r is 0 is there, but negative 1 is there. So we're going to be starting there. As our angle progresses this way, as our angle progresses, our r gets smaller and smaller and gets to 0. So it's going to approach 0 as my angle approaches, but this is actually the opposite direction. So as I move, it's going to approach 0. That chunk right there corresponds to that. Now, as I go from this angle to pi over 2, the r gets bigger and then smaller, right? So I'm going to do this one in red. And that's going to go all the way to almost pi. So as my angle starts here, because here to here produced that. So I'm going to go from here and almost all the way to pi. And what's that going to look like? It's going to start at 0. It's going to get big. It's going to come back to almost 0 at pi over 2, get big again, and almost back to 0. So that would make sense that it's this. It gets bigger. As I get closer to pi over 2, it comes all the way back. But then it gets big again. Whoa, I hate when that does that. It gets big and back to almost 0 at pi over 2 and gets big again. And then it goes back to 0. That corresponds to that 0 there. So that 0 is coming back to 0. Now from here to here, my r is negative. Well, that's from just before pi to just after pi. So from here to here, these angles, if you look, my r's are negative. So on the opposite side, it's going to go from 0 to big to 0. It's going to go from 0 to big to 0. So it's going to be produced that way. So if I did arrows of directionality, that would be helpful for you to see where we're going. So on the opposite side, I will do in gold. That would be this loop here, and it's going in that direction. If you can see that, that's kind of bad. A little too tight there. Then, in my beautiful fuchsia, so that's going to go from just after pi to before 3 pi over 2. So that's going to go from here to here, and my r is positive. Sorry, r is positive. So it's going to start at 0, get bigger, and back to 0. So in that range, it's going to start at 0. It's going to get bigger, and it's going to go back to 0 before I get to 3 pi over 2. Ooh, that's kind of cool. Let's try that again. I didn't want that to happen. So we're traveling this way. And then a couple more regions, and we're going to be done, but I'm running out of colors. So this kind of brownish, it's going to go from left of 3 pi over 2 to 3 pi over 2. That's left of 3 pi over 2 to past 3 pi over 2, but it's negative, so I'll go the other direction. That's going to be this little loop there. So this loop corresponds to the brown loop I have here, and the direction it's traveling is this way. Hopefully you can see that. That's just a blur. And then green, this will be my green. So this one goes from a little past 3 pi over 2 to almost 2 pi. So past 3 pi over 2 to almost 3 pi. And it goes from 0, big to 0. So 0, big to 0. And then the last piece, I'll use blue again. This one. So from here to here, I go the opposite direction, and it completes, yeah, it's going to be this piece here, the top half. So that top half will be that piece. And so you see the whole thing roll out. It's here, goes here, back, out here. It's going to go through, produce the orange, the purplish, the brownish, the greenish, and then back and finish. So that's important for you to kind of see the relationship and what these points are. These points is where it comes back to the origin and understanding how it's formed. One more of these, because these are kind of fun, I think. So blue, I'm going to make that fatter. So blue, well, 0, we're at 1. So that's easy, right there. But as my angle goes to pi over 2, so I start from here and I go to pi over 2. As I move, the r gets bigger, 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 and then all the way back to 0. So that makes sense. The r gets bigger, bigger, bigger. As my angle gets close to pi over 2, I get back to 0. So this would be that little limb. Then I'm going to do this one. So from pi over 2 to just past pi, it's going to get bigger than smaller. So from pi over 2 to just past pi, my r is negative. So instead of going this way, I'm going to go the opposite way. So clearly it's that loop right there. Clearly. And then my next little blip is this guy here. That's going to be from past pi to 3 pi over 2. So here's pi, and here's 3 pi over 2. And it's a little out and back. Well, here's my little out and back right there. And then from 3 pi over 2 to short of 2 pi, from here to short of 2 pi, I have a negative again. So instead of going this direction, I go the other direction. So that's going to produce this little loop. And then my last one I'll do in green. So from short of 2 pi to 2 pi, so that's from here to here, it's going to go from 0 to bigger. So I go from 0 to bigger, and that's my corresponding part. So that's changing from rectangular coordinates to polar, seeing the relationship, and that's it.